Hello Internet, welcome to another tutorial in the series of information theory and coding. We'll discuss symmetric key encryption, decryption today, and this is the most basic and classical method of cryptography, and everyone should have a thorough understanding of this in order to build up more complicated concepts in cryptography. What we have in symmetric key encryption and decryption is that the same key is used to encrypt and decrypt data. I'll talk about this in the explanation of this topic, but for the time being, another name which is given to this kind of encryption is that it's also known as a private key or a secret key encryption, where the cipher text is encrypted and decrypted using the same shared key. So that's the key point here. We know the fact that the plain text should not be sent on a channel because of security reasons. So we do something with the plain text so that the text is encrypted and not easily stolen on the network or on the channel. So if you were to draw the basic block diagram of a symmetric key encryption, decryption, that would look something like this. You have a message source that is generating plain text, then you encrypt that message source text with a shared key, and then it is sent over the channel. At the receiver end, it is decrypted using the same shared key which was used in the encryption process, and then you get the plain text message at the end user point. Now this can be understood more clearly with the techniques that are used for coding plain text. Please understand, these techniques are classical techniques. These are just the basic building blocks of how ciphertext started to be generated in the first place. So they are not necessarily are being used in the real world scenarios, but nevertheless they hold very important role in understanding these complicated new age techniques. The first technique that I talk about is the substitution technique, and the substitution technique further has two categories: monoalphabetic substitution and polyalphabetic substitution. I'll start with the monoalphabetic substitution, where, for example, if we have a plain text like this, which could constitute of any alphabet of English, then during the encryption process what we do is we we decide upon a shared key which is, for example, 3, or more precisely +3. Now this key is being used to encrypt this plain text into a encrypted text which will be shifted by 3 characters, because the key that we have decided upon to use would shift every alphabet by 3 positions or 3 characters. So what will happen is, if we were to transmit A on the channel, we'll transfer D instead. So we'll push 3 characters down to generate a new character which will be sort of encrypted or will be ciphered. So in other words, every character when shifted will have a new character in its place, and this will be known as ciphertext. So anybody who steals this text would not get any idea of what was sent originally unless he has the access to this key. So what I could write down here is that this key has shifted all the characters down by 3 positions. So I could say the shift by 3 characters down will generate a new text. And similarly here also the same key will be used at the receiver end. So if we receive a character like this, so every character which is received will be shifted up by 3 characters now, and the original plain text will be received. So if D is received, we'll again get A, and so on. So the thought process behind is the fact that this key which was decided upon was the same key to encrypt and decrypt data. Now this receiver which is receiving this ciphertext is a trusted receiver. So any trusted receiver would also be sent the information about this key, so that whatever it receives, it should perform the same function but in the opposite direction as performed by the transmitter. So that is how this monoalphabetic substitution technique takes place, where we substitute one symbol with the other, but the substitution of the symbols is pretty uniform. Now on the other hand, if we do a polyalphabetic substitution, which will look something like this. For example, we take up the characters of English alphabets, then we decide upon the key. The key is such that we shift the characters by an amount of by the number of characters position itself. So this key is a little more complicated than the key which was used in monoalphabetic substitution. Now what will happen here is, if A was transmitted, the position of A is fixed at first position, and similarly B is positioned at second, and C at third. So if A was to be transmitted, we'll shift A, which is the character, by the number of characters position itself. So A is at the first position, we'll shift A by 1 character. So while transmitting A, we'll send a B. The substitution of A will be B, and the deciding parameter is this key. And B will now be substituted by D, because we'll need to shift B by 2 positions and we'll get a D. And similarly C, which has position number 3, will be substituted by a new character which is 3 positions away from it. So we'll send an F, and so on. This way the encryption of the plain text is much more complicated than what was being done here in the monoalphabetic substitution technique, and the likelihood of this data being stolen and the likelihood of this data being decrypted by someone over the channel becomes very low, and the same key or the same algorithm or the same logic, whatever you may want to call it, is also informed to the receiver, so that whenever it receives a B, it should translate it automatically to A, and whenever it receives a D, it should automatically translate itself to B, and so on. So that is how polyalphabetic substitution technique takes place. But as you can see, this is one method of coding the plain text, because no matter how complicated the key becomes, the character is substituted by some other character in its own set itself. So that is what remains common in monoalphabetic substitution and polyalphabetic substitution, because in monoalphabetic substitution we could have a number of cases where we want to shift the characters by 3 positions, 4 positions, 10 positions in the forward direction, and then we could have as many possible cases in the reverse direction where we could shift the characters by 5 positions in the negative direction, and so on and so forth. And similarly, polyalphabetic substitution also, we could shift the characters by number of characters position, and similarly we could make much more complicated logics like shifting the position of a character by some power of the position of the character. So you can take it to any complicated level and design your own secret key, but please remember to send that secret key to the receiver also, because otherwise the data will be of no use to the receiver if he doesn't know how to decrypt it. Now, talking about the transportation technique. The transportation technique is or the transposition technique, another name for this is transposition. I'll show you with a block diagram where for example we have this text. So you could see that A is positioned at position number 1, position number 2 is a blank space, position number 3 is G, and similarly 4, 5, 6 have OOD, 7, 8 again is a blank, and similarly in the second line you have some characters positioned here. Now if I draw a secret key algorithm like this, for all the positions in the row, for all the possible positions in the row, what I'll do is I'll decide upon the fact that 1 will take up the position of 3 and 2 will go to 6. So I'll write down like this, and I could assign positions from any number to any number, and the 6 will take up 8, 7 will take up 5, and 8 will take up 7. So now the thought process behind is the randomness of the logic. Now with every set of columns that we could have text which could have as many columns as 100. If the text is a long sentence, then we could have 100 columns, and the possibilities of generating random combinations becomes manifolds when the number of columns or the number of characters per line increase. So for example, this is a rather small text in one line. We have generated this logic, which will be our key that will be used to encrypt and decrypt. So if I was to make a cipher text out of it, now using the same logic specified in this key, what I need to do is I need to transport the position of A to the third position. So A goes to position number 3, and similarly we need to send position number 2 to 6. So 6 will be replaced by a space. Position number 3 needs to be replaced by a fourth one. So G goes to 4th place, and 4th character needs to go to 1st place. So 4th one is O, so it goes to the 1st place. 5th character needs to go to position number 2, so 5th also becomes O. 6th character needs to go to position number 8, and 6th is D, and it goes to position number 8. 7th needs to go to position number 5, so 5 becomes a blank, and 8th needs to go to position number 7, so 7 also becomes blank. And similarly in the second line, first character needs to fill up the position at the third one, so F goes here. R needs to go to 6th position, so 6th position is taken up by R. I needs to go to 4th position. E needs to go to 1st position, and N, which is at the 5th position right now, needs to go to 2nd position, and so on. So what we've gotten here is the last D at 6th position needs to go to 8th position. We get a blank here, and the blanks have shifted their positions accordingly to this key. And similarly during the decryption process, the same key needs to be used, but in the reverse order, to transpose the positions of the characters, and that is why the name transposition technique or transportation technique is given to this substitution. And these were the techniques that are used for symmetric key encryption and decryption, where the private key or the secret key remains same to both sender and receiver to generate and decrypt the cipher text. And I hope this tutorial on the introduction of symmetric key encryption to generate cipher text was of help. If you liked the content of the tutorial, give it a thumbs up. Consider subscribing to the channel and sharing the videos if you wish to. And if you have any doubts, you could leave them in the comment section down below. I'll see you in the next video. Take care. Bye bye.